Hello, everyone, and welcome to 6th grade science. Today, we're going to discuss matter in motion. In our previous class, we have defined matter as anything that has volume and occupies space. We have also discussed how matter can change its shape and presentation from going from one state of matter to the next. It has gone from liquid to solid to gas to plasma and back and forth, depending on how much energy we apply to it and how further apart or close together are the molecules that make up that matter. Today, we're going to discuss how everything moves, okay? We might think that the only thing that is going on at the time of movement is how much force we apply onto an object to make it move, or how we're willing our brain to move our arms, our legs, everything. But there are a lot of things going on at the same time, many things being involved in movement. Okay, so today we're going to discuss some of them, not all of them, but some. What changes when something moves? How can you tell how fast something is moving? You can move and objects all around you can move. But how can movement be measured? In this lesson, you will explore motion, speed, velocity, acceleration, and how to measure movement on Earth. We have made that last specification about movement on Earth because we know that the conditions of each planet is totally different from one another. We know that Venus, for example, since it's closer to the sun, it's very, very hot, while Neptune, who is further apart, it's a little bit colder. We also know that the gravity here is different from all of the other planets, satellites, and asteroids. For example, the gravity on Jupiter will probably crushes down. Even if there's a way that we could travel to Jupiter and stand on its surface, we will probably be crushed immediately because the gravity on it is so much stronger than here on Earth. So let's discuss speed and velocity. Many people assume wrongly that speed and velocity are the same thing. We might think of that, but they are totally different concepts. In fact, velocity itself involves the concept of speed, but we have to take on a little bit more of detail. Scientists investigating an object's motion will also want to know in what direction the object is moving. When both the speed and direction of an object are known, the object's velocity can be defined. So we have speed. Speed describes how fast an object is moving. We can say that a car is moving at 80 miles per hour. We can say that flash moves at an average speed of, 2,000 miles per second. We have defined how fast an object moves by explaining the distance that one must travel and how much time we need to travel that distance. And then we have velocity. When we're talking about velocity, we're describing both the speed and the direction of the object that is moving. For example, let's pretend that we have a speeding car, okay? With the speeding car is going to travel down a curvy path. So a car traveling on a curvy road with its cruise control set at 88 kilometers per hour would stay at a constant speed of 88 kilometers per hour. The speed is never changing. However, the car's velocity would vary, so its speedometer always reads the same. The car's velocity changes every time the car changes direction on a curve. Okay, so if we have a car, the car is going to stay at a constant speed. That means that the speed will never change. It's going to remain traveling at 88 kilometers per hour. But every time that we move our car towards the left, towards the right, while we're driving on that curvy road, we're changing the direction that our car is moving. The speedometer is going to read the same amount of kilometers per hour because we're not changing the speed. But when we change the direction of our car, we're changing the velocity of the car. See? That's roughly the difference between speed and velocity. Now to calculate speed. Calculating speed is actually easier than you might think. When we say the speed of an object, we already make the calculations. How do you use measures of speed and distance in everyday life? Knowing your speed and the distance you need to travel allows you to estimate how much time it will take to reach a certain destination. Suppose you wanted to travel 800 kilometers from Atlanta to Indianapolis. How long would it take to get there in a car traveling at an average speed of 80 kilometers per hour? They have given us the distance that we must travel, and they have given us the speed at which we will travel. We can then calculate the time that we need to do that small trip from Atlanta to Indianapolis. To calculate the time you will need to travel, you divide the distance that you will go by your average speed. So we have 800 kilometers, which is the distance that we must travel, and the speed at which we're traveling, which is 80 kilometers per hour. 800 by 80 gives us a total of 10, and we can nullify kilometers by kilometers like we do when we are simplifying fractions. Then the only measurement that we have left is hours. So it would take you a bit more than 10 hours of driving to complete this trip, even if you did not stop for food and fuel. Why does it say a bit more than 10 hours? Because this calculation is not exact. We can only make certain experiments to see how much the difference or the margin of error is going to be. In this class, we're not going to calculate the speed of any of the objects. We are just going to make a discussion of the theory that is behind these calculations, okay? When you go to high school, you will start seeing physics, okay? The science behind the movement of everything. And you will discuss further, in more depth, what calculating speed is going to be. Now, every time that we discuss cars, especially boys who really are into cars, when we're talking about, I don't know, Lamborghinis, Mustangs, Ferraris, and so on, we say, oh, this car is so fast, it has this horsepower, whatever, its design. Every year, people who design cars, those engineers try to take the speed a little bit further. That is still safe for us to drive. So, for example, race cars are constantly being redesigned to go faster while maintaining safety. There is certain speeds that a car might travel, but our bodies will not be able to sustain. So that's why we're trying to keep as safe as possible while driving as fast as our science will let us. Sometimes weather or accidents slow the average speed of the race cars. In 1911, the first year of the Indianapolis 500 race was held. The winning car averaged speed about 120 kilometers per hour. In 2006, the winning averaged at 370 kilometers per hour. See, in more than, I don't know, roughly 90 years, we have made a lot of advancements. We have gone from 120 kilometers as our limit to 370. And there are a lot of cars that might travel to a further speed, but as I said, it's not safe for us to do so. So we are still trying to see how fast we can travel and how we can still keep it as safe as possible for us who are going to be driving those transportation methods. Now, let me give you another example about how speed can actually change from depending on its position. When we're biking, have you ever stopped at the top of a steep hill, then speed down on a skateboard or a bicycle? Were you going at the same speed at the bottom of the hill as you had been near the top? Pause the video, think about it for a second. If you're at the top of the hill, would you be traveling at the same speed on top of the hill as you are when you reach the bottom? There is always this scene in a cartoon in which there's a character driving down a hill and they cannot stop due to the velocity and the speed they are traveling to. So, changing the speed. Usually, when you think of a moving object, you think of it as it moves at a constant speed. How can you tell for sure if you're moving at a constant speed or if your speed changes? One way to do this is to measure your change in position, how far you move during a standard period of time, such as 1 second. So, when we're moving, we're not moving in the same place. If we move our hand is changing its position from one place to another. When we are traveling by a bike or by a skateboard, we're changing our position from whatever place we were to the place we are traveling to. So, a biker is paddling, this is another example. A biker is paddling along the steady rate on flat ground. Their average speed is 3 meters per second. If their speed is constant, they will travel 3 meters in the first second, another 3 meters in the next second, another 3 meters in the following second, and so on until they put on the brakes or slow down or pedal faster to speed up. An object traveling at a constant speed moves at the same distance during each second of travel. We have defined speed as the amount of distance that we can travel in an amount of time. If we see, for example, the example of the biker, I know I said example twice, but in here we see the biker is going to travel 3 meters per second. That means that in every second, it's going to move further away 3 meters. 3 meters the first second, 3 meters the next second, and so on and so on. The speed is going to remain constant, non-changing. But if we move that biker, instead of paddling along a very steady rate on a flat ground, and we move that flat ground into a hill, we're going to obtain different results. Okay, here is another example, another condition, but using the same biker. What if the biker on the bicycle stops at the top of a steep hill? How will their speed change when they start down? In the first second, they move a short distance down the hill. They are moving fast, only 1 meter per second, not too much. During the next second, they pick up speed and are moving at 2 meters per second. But since they are on a steep hill, their speed continues to increase. After several more seconds, they are moving at 6 meters per second. Coasting down a steep hill on the bike is an example of acceleration. Scientists define accelerations as the rate of change of an object's velocity. In our previous example, we discussed how it's going to remain at a constant speed. But once we change the position, we're changing the velocity of our biker. It's not going to be 3 meters per second anymore. It's going to move from 1 meter per second up to 6. Why? Because when it goes from the top of the hill downwards, it's going to be traveling faster and faster because we're having a change of position. Changing that position and changing the speed is what we know as acceleration. Acceleration is defined by any change on its velocity. And I mean for the good, for the better, or for worse. If we stop, we are changing the acceleration. And if we go further away, then we are changing it to more. We're changing that velocity. So accelerating. You probably think of something speeding up when you're speaking of acceleration. This is only partly true. Scientists define all changes in speed and direction as acceleration. An object that is slowing down has negative acceleration. Okay, in math class, we have already seen how there are positive numbers and negative numbers. Acceleration is not just adding speed. We can also decrease the speed at which we're going, and that still counts as acceleration. It's just going to be a negative acceleration. If we move our hand really fast from one place to another, we're trying to pick up the speed. While we pick up the speed, we might accelerate, have a positive acceleration in our movement. But if we slow it down and halt, then we have a negative acceleration that is equal to the positive acceleration, decreasing it and getting a speed of 0. Now we're going to talk about the force. And even though I added a lot of images from Star Wars, we're not going to discuss the force from the Great Jedis. What happens here? The universe of Star Wars is actually based a little bit on science, like all science fiction is. When we see Darth Vader choking somebody on the air using the force, it's not their telepathic ability. They're actually applying force around the throat or whatever they are trying to lift up into the air. Force has its own definition. So, a force is a push or pull of one object exerts on another object. It takes force to start a lump of matter moving and stop it from moving or change its velocity. Okay, the same examples that we have been discussing before, the car and the biker. When we are moving our car down the curvy road, we have an engine that is forcing that car to make its wheels spin. And that is going to accelerate and grab and direct the speed of the car. When we are on the bike, we are the ones pushing those pedals to make the wheels spin, and then we are going to be driving our bike. We are pushing or pulling another object, okay? And the other object is ourselves. We are the ones applying that force. One type of force is friction. Friction is a force that opposes motion between the surface of two objects that are touching. Friction depends on the kinds of surfaces between the two objects and the amount of forces pressing the two objects together. Friction causes moving objects to slow down and eventually stop. It always acts in the direction opposite to the movement of an object. Okay. Friction is caused by two objects that are touching, okay? They are applying one force over the other. When we rub our hands and we move them as fast as possible, we are generating heat because we are applying force from one hand to the other, creating friction. That friction is going to translate into heat energy. We can also do another example. We have one of our hands and then the other. For this hand, we're not going to apply any force, but for this one, we're going to try to push it as further away as we can. When we do this, our hand is pushing the one that is not applying any force. But if we apply the same force from one hand to the other, and we continue to push, our hands are not going to move from one place to the other. Why? Because we're applying the same force, but in a different direction, which nullifies the movement of an object. Friction also occurs between two touching objects that are just sitting still. In this case, the frictional force between two objects is just great enough and in the right direction to balance out any other forces that are acting on the objects at the same time. The total force of the two objects is 0, and the objects won't start to move. There's no acceleration. The more force pressing two objects together, the more friction there is between two objects. So, right now, everything around, for example, my room, is staying still. But that does not mean that since they are not moving, they are not applying any force. Friction occurs between any objects that are touching, okay? So for example, in here, I have two books, one over the other. They're applying a force that is going to be 0, and they are not going to move, but they are still applying friction to one another. Depending on how much force we apply onto an object, we can change the amount of friction that we're given it. For example, right now my hands are barely touching. There is friction between the objects, but not much. If I apply more force and I try to push my hands onto one another, then I'm going to increase the friction of an object. The friction, like we have explained in the previous slide, can also stop our movements. For example, when you guys, have you ever been on a very slippery floor that has been wet and you guys have your shoes on? You can glide over the wet floor and just slide one way or another, and it's pretty fun. But if the floor were not wet, if the floor were not slippery, the friction would be way higher and you would not be able to slide as easily on the floor as it would be if it were wet. We can also talk about friction causing music. It can also cause noise. For example, when we grind our teeth together, we are causing certain noise. When we move our tongue and brush it against the roof of our mouth or our teeth, that's how we are making the pronunciation of words. We can say P, and our lips are going to move against one another, causing friction, and that friction is what causes the sound, or the sound if we brush our tongue to our teeth. Friction can make beautiful music. Sounds produced by the friction of two objects rubbing together can be irritating or a blessing. Squeaking chalk across the blackboard makes people cringe. Crickets attract their mates by rubbing their front wings together to make chirping sounds. But rubbing a bow across the strings of a violin or strumming a guitar string can start the strings vibrating and make music. Okay? We know that there are 3 types of instruments. One of those are those who move with strings, like violins and guitars. Every time that we brush those strings, every time that we strum them with a bow or with our fingers, we're causing vibrations to go along the string, causing that sound. But when we brush it, we are causing a friction that is going to cause those vibrations, which at the same time will cause that music. I know I said cause too many times, but I'm trying to explain the process. Now sound. The quality and amount of sound produced when two objects rub together partly depends on the amount of friction between them. Bows of a string instrument are made by attaching hairs from the tail of a horse to a wooden bow. The more friction that there is between the bow and the strings, the easier it's to set the strings in motion when they cross them. The vibrations of the violin strings make the musical sounds you hear. Okay, give me a second while I look for a ruler. I don't have, I think I might broke something, but that's okay. When we have a violin, we have our bow. I do not have a violin. I do not know how to play one, but I can understand the physics behind its movement, its sound. Let's pretend that this is a bow. Depending on how much force I apply or the movement, inclination of the bow that I apply into my violin, the violin is going to create different noises. If I barely touch my violin with the bow, it's not going to make a very loud sound. But if I glide it over it softly, applying certain force is going to create more friction, which will in turn cause the musical sounds that you guys hear. Friction makes things hard to move. Transportation engineers and designers develop oils and lubricants to reduce friction in cars and other moving parts. Why? We have talked about how friction can slow you down. Sometimes friction can also cause damage. For example, we're rubbing our hands together. We're causing heat. But if we continue to do so repeatedly for a long period of time, we can damage our skin because the heat that we are producing will probably burn the epidermis, and it's going to be very painful. So to avoid friction destroying things and to make the movement easier, many scientists have developed oils and lubricants which make it easier for them to move. For example, what I said before about the floor being totally wet and you can slide along it from one place to another, well, the water is behaving as a lubricant, reducing the friction of the floor and letting you glide from one place to the other. Okay. They also use wind tunnels to test the friction between high-speed air and car bodies. We have discussed before in our previous classes how air actually opposes our movement. And depending on the state of matter, we can feel certain things. For example, when we are moving our hand through the air, there's gas. The particles are further apart from one another, which makes it easier for us to move in whatever direction we want with whatever speed we want. When we go into the water, when we're going to a pool or to the beach, every time that we try to move or run, for example, if you have tried to run with your knees under the water, you're feeling certain opposition to your movement and you cannot move as fast as you would like to. And in the case of solids, you cannot go through solids as of yet. Since you cannot go through solid, your movement stops completely once you try to cross it. So they have been trying to test the friction between high-speed air and car bodies because the car and the air are going into different directions, causing friction. Even though we cannot see the air, we know that it's there, it has a volume, and it can oppose our movement, causing friction. Streamlined vehicles slip through the air with less friction, so they use less gasoline and therefore cause less air pollution. The force produced by the engine of a car couldn't push the car down the road without the friction between the tires and the road. Drivers find that they need more friction that they try to climb a steep hill on ice or stop quickly on badly worn tires. Think of what happens when you try to walk fast or run on ice. It's not easy for us to move on ice unless we have skates. Let me see if I can draw it for you. I'm going to draw a very badly drawn shoe, and it's because I'm on my laptop and I have no idea how to draw on it. So let's pretend that this is a very nice shoe. And this is a very nice ice skate. Wait. Be patient, please. Okay. When we're moving on ice with our shoes without using any type of ice skates, we are probably going to sleep, we will not be able to control our movements, and we will move at a very slow pace. In the case of ice skates, they have this metal lining at the bottom of the shoe that reduces the amount of space that is between the ice and your shoe, reducing the amount of friction, letting you glide from one place to another. That's how ice skating works, by reducing the friction using the ice skates. Okay, that's it for today. I'm glad to inform you that you have no homework today, but I would like you to review what today's subject was. Inspect your movements, see what forces are being applied to all of the things that you do in your daily lives, and see if this class helped you have a little bit more of an in-depth supposition of how everything works. So, see you next week. Have a wonderful weekend.